Hello everyone, so we are close to the end of the first unit, but we need to talk about complex conjugate coordinates and point sets before we finish. So far we have said that we can represent complex numbers in this form, and recall that we wrote a complex number and its conjugate as follows. So using these two, actually we can write the x coordinate as 1 over 2 z plus the conjugate of z. Notice that here the yi's cancel and 2x becomes 2x over 2, which is equal to x. And similarly, we can write the y coordinate of the complex number using conjugates as follows: 1 over 2i times z minus the conjugate of z. Now we are going to talk about something pretty important for the following parts of the course. We are going to talk about point sets, and we are going to start with neighborhoods. So a delta neighborhood of a point z0 is the set of all the points such that z minus z0 is smaller than delta, where delta is any positive number. And a deleted delta neighborhood is the delta neighborhood that does not contain the point z0. So this distance must be greater than 0, so z cannot be z0. So this set does not include the point z0. So it's basically the points at a given distance. The distance is delta, obviously. Another important concept is the concept of limit points. So z0 is a limit point of S if every deleted delta neighborhood of S of z0 contains points of S. So let's just visualize. So let's say we have this set of points. So I'm going to delete this. And let's just visualize it is such a shape where the distance is always 1. So let's just consider the point here. So every deleted delta neighborhood, I mean, even if you get so close to the point, every deleted delta neighborhood contains points that are in this set, in this region. And let's look at the boundary. For this boundary, every deleted delta neighborhood contains some points that are in the circle. And actually that brings us another definition. A set S is closed. A set is a closed set if every limit point of S is in S. So let's again look at the same set of points. So the absolute value of Z is less than or equal to 1. So let's consider, again we said that this is a limit point and it is in the set. And let's consider a point just outside the set. So now for this point we can find the deleted delta neighborhood choosing a very small delta such that there isn't any point in S in that deleted delta neighborhood. Which means that a point just outside this set is not the limit point. And all the points inside the set and on the boundary are limit points. So we can say that all limit points belong to S, which means this set is closed. And we have another definition, bounded sets. Bounded sets. We say that a set is bounded if we can find a M such that, and this notation is, well, let's use it in another video, such that we can find an M such that M is greater than the absolute value of Z for every Z in the set. So if we can find such an M, we say that the set is bounded. Okay, and we have another important definition, interior, exterior, and boundary points. A point Z0 is an interior point of S if we can find if there is a delta neighborhood of Z0 whose all points belong to S. So let's again use our example. The absolute value of Z is greater than or equal to 1. So the points inside the circle, for all of them we can find a delta neighborhood whose all points belong to S. I mean, let's just consider it here. We can choose this thing as our delta neighborhood, choosing such a delta. Then all the points belong to S. Now let's look at the boundary points. Even if we choose a delta that's so small, we'll have points outside S. So these are not interior. So I hope you get some kind of intuition by that. And boundary points are points, let's write it, boundary points are points whose delta neighborhood contains points inside and outside S. So again, let's draw it. We have the absolute value of Z is less than or equal to 1. Let's consider this point. For every single delta neighborhood that we are going to choose, even if we choose the delta so small, we are going to have points inside S and outside S. So all the points here on the bounds are boundary points. Exterior points are points that are neither interior nor boundary points. And the last definition we are going to do is open sets. An open set is a set that consists of only interior points. So this is just a definition, and we are not going to go into much detail here, but we are going to talk about them more if we need in the future, in the following chapters of the course.